Okay, sir.
ठीक है जी ओके
Assalamu alaikum. I'm Nadeem Khan from GIK School and College. Today I will give you a lecture about the grade 9th subject chemistry, chapter number 2, atomic structure. Let me announce the topic, whatever topic we are going to discuss today. Let me start with the atom. You know, the whole universe is made up of matter and energy. Matter is composed of atoms. Atoms have a central part which is positively charged called nucleus. So, and electrons revolve around the nucleus. Proton, neutron lies inside the nucleus. So today, in my lecture, I will give you an idea how nucleus was discovered. Let's say this is the atom. This will be the nucleus. How this was discovered. This is my topic today. So let me announce my topic. The name of my topic is Discovery of Nucleus, or it is also known as Rutherford's experiment. In exam, you can also have such a question, how nucleus was discovered. It may also be just like this. What was the Rutherford experiment? How he performed this experiment? What he concluded? And what were the defects associated with this? It can also be a Rutherford's model, not the experiment, model. So many questions, but the solution is same. I'm proceeding towards the experiment. What was the experiment and what to do with? Rutherford took a very thin gold foil. This is a paper foil made up of gold. How much thick? Round about 1 by 1000 part of a millimeter. 1 by 1000 part of approximately, this is not the very correct. This is the thickness of this gold foil. He took a reactive element, you know, radioactivity. This is a separate topic, but we will discuss it later. This is a radioactive element. This radioactive element was enclosed in a block of lead. This is lead. Lead block all type of radiations. This radioactive element, this was radium. It emits radiation like this. It has many types of radiations, alpha, beta, gamma, but Rutherford only took alpha particles. He took only alpha particles. He passed these alpha particles through this thin gold foil. This is gold foil. And he placed a screen around this. This screen actually detects any type of radiation which falls upon it. This is a screen. This is a fluorescent screen. It may be a photographic plate. So actually he took a fluorescent screen. When any radiation strike with this screen, it produces flashing or sparkling or fluorescence or glow, whatever you call it. So when he passed these radiation through this gold foil, what was he considering? What was he supposed to do? He was absolutely sure that the thickness of this gold foil is very, very small. So almost 100% of the radiation will directly pass. So whatever he was he was thinking that almost all of the radiation will pass like this. And wherever this radiation strike, it produces glow, what we call in Urdu chamak, fluorescence, glow. So, but actually when he performed this experiment, he also observed that few of the radiation were deflecting like this at large angles, and some of them were totally rebounds back like this. Some of the radiation, but these rebounds back radiation were very small. Almost more than the 99% of the radiation were directly passed. How these radiation are bounced back? Why? This was the main problem for Rutherford. What's the reason? While the rest of them are passing directly, most of them, not the rest of them, and why a very few they rebounds back? Why? So what was the reason? So he wrote a sentence in his publications that one can never believe, if you have a 12 inches long artillery shell, it goes, strike a tissue paper and come back. Will anyone believe in? Never. No one can believe it. Why? Artillery shell, top ka gola, goes, strike a tissue paper and come back. Is it possible? Never. So in the same way, how this was just like a tissue paper, this gold foil. These are the artillery shells. It must goes straight and it must pass this thin gold foil. Why it was deflected? So he concluded that there is something wrong here. So actually some radiation were passed. Let me clear that alpha particle carry +2 charge, doubly positively charged. When this radiation passes through the gold foil is made up of atom. Let me explain. Let's say this is a single gold atom. An atom has most of the space empty, vacant. Nothing is there in an atom. It has a central part and electrons. But most of the space in an atom is empty. So that's why most of the radiations were directly passed. Because when the radiations were coming, these are the radiations. They are coming. And if they strike the electrons are very small as compared to the huge alpha particle. So electron cannot block them. It's impossible for the electron to block these particles. That's why the most of the radiation were directly passed. Yes, but there is some portion which is positively charged. When any of the radiation which goes close to this part, these were deflected. And this is indicated here. Any of the radiation which falls directly upon this central positively charged area, it was rebounded back. So the few radiations which were rebounded back, it shows us, it gives us a clue about the presence of a nucleus in an atom. So there is some positively charged area which repels the doubly positively charged alpha particle. So he concluded that there is a central positively charged area inside the atom, what he called nucleus. So in this way he discovered the nucleus. Then he planned a model, what he called Rutherford atomic model, in which he gave some points. Let me explain those points. He said that most of the space in an atom is empty or occupied by electrons. So due to the very large size and positive charge of alpha particle, it is impossible for the electron to deflect the alpha particles back. That's why most of the radiations were directly passed. Those radiations which come very close to the nucleus, they were deflected at the large angles. And those radiations which fall directly upon the nucleus, they were totally rebounded back with the same angle at which they were allowed to strike. So Similarly, he said that atom, the nucleus is very, very small as compared to the total size of the atom. Let me explain this. If this is the atom, the nucleus will be this almost invisible. This means the nucleus is very, very small. There is let me give you an analogy. If you magnify an atom up to a cricket ground, there is a cricket ground in London, what we call oval ground. If you magnify an atom, if you consider an atom is the oval ground, then what will be the nucleus? You know, nucleus will be, let's say this is the oval ground. This is the oval ground. You know, what will be the size of the nucleus? I am just comparing the size of the whole ground and the atom and nucleus. This is the oval ground. This is the pitch. You know the pitch. Here is the batsman. Here is a bowler. Now, you know, what will be the nucleus? If the ground is atom, this whole ground is atom. The nucleus will be the size of an apple or tennis ball lying at the middle of the pitch. So can you compare a tennis ball or apple with the whole ground? And this way I can make sure this that the size of the atom is very large, but the size of the atom nucleus is very small, but it carries 99.9% of the total mass of the atom. You know, it's very small, but it is very heavy. It's very small, but it's very heavy. So most of the space in an atom is occupied by electrons. There is a central positive charge area inside the nucleus, inside the atom, which is called nucleus. Similarly, the nucleus contains almost 100% of the positive charge. So the nucleus carries almost all the positive charge, and all is concentrated. Similarly, the nucleus carries 99.99% mass of the total atom. So it's very small, nucleus is very small, but it's very heavy. So this was the Rutherford model, and he makes his conclusions or points, and this is the called Rutherford model, and this is the experiment. And let me repeat it in a few words. Rutherford took a very thin gold foil. He allowed the alpha particle to strike over this thin gold foil. He took radium as a radioactive source and enclosed it in a lead made block. Actually, lead stops all the radiations going out in other direction and allows the radiation only through this its open end. When this radiation passes through the gold foil and strike the screen, produces fluorescence. Some of the particles were bounced back, and these bouncing back of the particles indicates that there is some positive charge area inside the nucleus, which has deflected the doubly positive charge alpha particle, and this positive charge area was nucleus. And this way nucleus was discovered. If you have any questions, I have a page on the Facebook, Exploring Chemistry. You can ask, and you have my mobile number, WhatsApp number. You can contact me. I thank you all. Thank you, sir. Sir, ये हो गई है. Can I have this? ठीक है सर. ठीक है सर. ये सर.